Okay, so we're going to start trigonometry today. And then after this, we'll just have one more chapter left on measurement, and then we'll have some time at the end to do some review for your final exam. Grab the booklet here, Kiana. So let's skip to page number 5. Let's see if this works. Nope.
Pythagorean theorem. Pythagorean theorem, which is fun on its own, but you'll see as you learn more and more mathematics, it's one of those cornerstone theorems of really all of math. It's useful in geometry. It's kind of the backbone of trigonometry. You're also going to use it to calculate distances between points. So it's a good thing to really make sure we know well. So enough talk on my end. Let me tell you what the Pythagorean theorem is. So if we have a triangle, and the triangle has to be a right triangle. So it has to be a right triangle, which means that one of the three angles in the triangle have to be 90 degrees. And you specify that it's 90 degrees by drawing that little box right there. So that right there is, let me do this in a different color. That right there is a 90 degree angle, or we could call it a right angle. And a triangle that has a right angle in it is called a right triangle. So this is called a right triangle. Now, with the Pythagorean theorem, if we know two sides of a right triangle, we can always figure out the third side. And before I show you how to do that, let me give you one more piece of terminology. The longest side of a Pythagorean of a right triangle is the side opposite the 90-degree angle, or opposite the right angle. So in this case, it is this side right here. This is the longest side. The way to figure out where that right triangle is, and it opens into that longest side. That longest side is called the hypotenuse. And it's good to know because we'll keep referring to it. And I just so we always are good at identifying the hypotenuse, let me draw a couple of more right triangles. So let's say I have a triangle that looks like that. Let me draw it a little bit nicer. So let's say I have a triangle that looks like that. And I were to tell you that this angle right here is 90 degrees. In this situation, this is the hypotenuse because it is opposite the 90-degree angle. It is the longest side. Let me do one more, just so that we're good at recognizing the hypotenuse. So let's say that is my triangle, and this is the 90-degree angle right there. And I think you know how to do this already. You go right, what it opens into, that is the hypotenuse. That is the longest side. So that is the hypotenuse. So once you have identified the hypotenuse, and let's say that has length c, and now we're going to learn what the Pythagorean theorem tells us. So let's say that c is equal to the length of the hypotenuse. So let's call this c. That side is c. Let's call this side right over here. Let's call this side right over here a. And let's call this side over here b. So the Pythagorean theorem tells us that a squared, so one of the shorter sides, the length of one of the shorter sides squared, plus the length of the other shorter side squared, is going to be equal to the length of the hypotenuse squared. Now, let's do that with an actual problem, and you'll see that it's actually not so bad. So let's say that I have a triangle that looks like this. Let me draw it. Let's say that this is my triangle. Looks something like this. And let's say that they tell us that this is the right angle, that this length right here, let me do this in different colors, this length right here is 3, and that this length right here is 4. And they want us to figure out that length right there. Now, the first thing you want to do before you even apply the Pythagorean theorem is to make sure you have your hypotenuse straight. You make sure you know what you're solving for. And in this circumstance, we're solving for the hypotenuse. And we know that because this side over here, it is the side opposite the right angle. If we look at the Pythagorean theorem, this is C. This is the longest side. So now we're ready to apply. We're ready to apply the Pythagorean theorem. It tells us that 4 squared, one of the shorter sides, plus 3 squared, the square of another of the shorter sides, is going to be equal to this longer side squared. The hypotenuse squared is going to be equal to C squared. And then you just solve for C. So 4 squared is the same thing as 4 times 4. That is 16. And 3 squared is the same thing as 3 times 3. So that is 9. And that is going to be equal to C squared. Now, what is 16 plus 9? It's 25. So 25 is equal to C squared, and we could take the positive square root of both sides. C, I guess, just if you look at it mathematically, could be negative 5 as well, but we're dealing with distances, so we only care about the positive roots. So you take the principal root of both sides, and you get 5 is equal to C, or the length of the longest side is equal to 5. Now, you could use a Pythagorean theorem if we give you 2 of the sides to figure out the third side, no matter what the third side is. So let's do another one right over here. Let's say that our triangle looks like, something like, let's say our triangle looks like this, and that is our right angle. Let's say that this side over here has length 12, and let's say that this side over here has length 6, and we want to figure out this length right over there. Now, like I said, the first thing you want to do is identify the hypotenuse, and that's going to be the side opposite the right angle. We have the right angle here. You go opposite the right angle. The longest side, the hypotenuse, is right there. So if we think about the Pythagorean theorem, that a squared plus b squared is equal to c squared, 12 you could view as c. This is the hypotenuse. The c squared is the hypotenuse squared. So you could say 12 is equal to c. And then we could say these sides, it doesn't matter whether you call one of them a or one of them b. So let's just call this side right here, let's say a is equal to 6. And then we say b, this colored b, is equal to question mark. And now we can apply the Pythagorean theorem. A squared, which is 6 squared, plus the unknown b squared, plus b squared, is equal to the hypotenuse squared, is equal to c squared, is equal to 12 squared. And now we can solve for b. And notice the difference here. Now we're not solving for the hypotenuse. We're solving for one of the shorter sides. In the last example, we solved for the hypotenuse. We solved for c. So that's why it's always important to recognize that the a squared plus b squared plus c squared, c is the length of the hypotenuse. Let's just solve for b here. So we get 6 squared is 36 plus b squared is equal to 12 squared, that's 12 times 12, is 144. Now we can subtract 36 from both sides of this equation. Subtract 36, those cancel out. On the left-hand side, we're left with just a b squared is equal to, now 144 minus 36 is what? That is 144 minus 30 is 114, and then you might subtract 6 is 108. So this is going to be 108. So that's what b squared is, and now we want to take the principal root, or the positive root of both sides, and you get b is equal to the square root, the principal root of 108. Now let's see if we can simplify this a little bit. The square root of 108, and what we can do is we can take the
Okay, I'm
prime
going to stop
factorization of...
there because now he's getting into something that's not part of our course. So we just showed you two different ways or two different types of problems that you're going to see with Pythagorean theorem. It can only be used when you have a right triangle, and you're either going to be, well, you're always going to be given two sides and you want to find the third side. Sometimes you're looking for the hypotenuse, sometimes you're looking for one of the other sides of the triangle, known as the legs of the triangle. So it just all depends, what are you given? Okay, so again, the hypotenuse is the longest side of the right triangle. The legs are the two shorter sides that form the right triangle. And Pythagorean relationship is a relationship between the lengths of the sides of a right triangle. The sum of the areas of the squares attached to the legs of a right triangle equals the area of the square attached to the hypotenuse. You see, this is where Pythagorean theorem actually came from initially, is that mathematicians many years ago started working with right triangles, and they found the area of the squares that were built off of each side of a right triangle. And they found that the two smaller squares, and this square, which was a by a, the area is a squared. This square is b by b, area is b squared. The area of these two squares added up always equaled the area of the square coming off the hypotenuse. And that's where Pythagorean theorem actually came from. But we use it to find missing sides in right triangles. As long as we have two sides of a right triangle, we can find the third side. So let's look at this first example. It says make a sketch of a right triangle with legs of 18 and 24 feet, and then use Pythagorean relationship to determine the length of the hypotenuse. So sometimes the triangle is given to us, other times we need to construct it. And it's not necessarily going to be drawn to scale, but that's okay. We will go with the numbers that were given. One leg is 18 feet, the other leg is 24 feet. The legs are always the two sides that make the right angle. One of them is A, one of them is B. It doesn't matter which one is A and which one is B. I can switch these two around if I want. It won't change the answer. But you just have to make sure that you always use the hypotenuse, which is the side across from the right angle. It's always the longest side. That is always C. Okay, Jace? Okay, so Pythagorean theorem says that a squared plus b squared equals c squared. So we said that a was 24 and that b was 18. So that's what it'll look like in Pythagorean theorem. Now on the video, he squared each number first and then added them together. But you can do those on your calculator in one step. We can go 24 squared plus 18 squared. Most calculators now do order of operations, where they square the numbers first, then add them together, and that'll give you 900. That's what c squared is. To find out what c is, then we need to get rid of the square and the opposite of square and the square rooting. And whatever we do to one side, we have to do the same thing to the other. So on the right side, square root and square cancel each other out. And on the left side, the square root of 900, I think, is 30. So there's your answer. There's the length of the hypotenuse. And again, when it says determine, that means you got to show your work. Where's that answer coming from? All right, example 2 says use the Pythagorean relationship to calculate the distance saved by walking along the diagonal. So it looks like a soccer field. And you can walk along the edges and go 60 meters down and then 100 meters to the right. That's a total of 160 meters. But it's quicker to walk across the diagonal. Put your computer away, Jackie. It's quicker to walk across the diagonal, shorter. So let's see what that distance is. Again, the diagonal in this case is the hypotenuse. It is the side across from the right angle. So if we kind of put our triangle there, it'll look something like that. And Pythagorean theorem says that a squared plus b squared equals c squared, where a and b are the two legs of the right triangle. They are the two sides that make the right angle. The hypotenuse, the side across from the right angle, the longest side, is c. So again, Pythagorean theorem says that a squared plus b squared equals c squared. We said that little a is 60 and little b is 100. We could switch those two around, it wouldn't change the answer. 60 squared plus 100 squared is the same as 100 squared plus 60 squared. But now we will find out what c squared is by putting the left side into the calculator. We'll get 13,600. And then we take the square root of both sides to find out what c is. And this one might have to be rounded. We'll see. No, I don't. Maybe. Yeah. We're going to have to round this off. It's 116. We'll round to the nearest tenth. 116.6. And I'll use approximately equal to 116.6 meters. The question says, how much distance is saved by walking along the diagonal? So like we said, if you walk along the edges, it's 160 meters. The diagonal is 116.6 meters. So the subtraction, or the difference between those two, will be how much is saved, what distance is saved. So we'll subtract them. So approximately 43.4 meters is saved by walking across the diagonal instead of along the edges. So this next one says, if a triangle has those side lengths, and then it says if the angle at y is exactly 90 degrees, what should the distance between x and z be? So basically we're going to see if this actually is a right triangle. If you go 5 squared plus 12 squared, what should the hypotenuse be? So we're going to check to see what c squared should be, and then we'll find out what c should be. It doesn't matter if it's a squared plus b squared equals c squared, or c squared equals a squared plus b squared. It doesn't matter. But a and b are the two legs of the triangle. It doesn't matter which one is a and which one is b, but they are the two legs, the sides that make the right angle. So I said that a was 5 and b was 12. So let's see what we get when we go 5 squared plus 12 squared. 169. And when we take the square root of that, we're actually going to get 13. Square root and square cancel each other out on the left, and on the right, the square root of 169 is exactly 13. So this tells us that triangle is not a right triangle. If it was, the hypotenuse would be 13, not 12.8. So again, this is a conclusion we can make. This is not a right triangle. If it was, then the hypotenuse would have to be 13, not 12.8. Because it's a little shorter than 13, it means the angle at y is a little smaller than 90 degrees. That's what it tells us. The longer the hypotenuse, or the longer the side opposite that large angle, the longer it gets, the bigger the angle across from it will get. Example 3 says George is making a rectangular picture frame. He wants to check that the frame has, pick up the booklet here. He wants to check to make sure that the frame has square corners. Calculate the length the diagonal must be for the frame to be square. So this is something that carpenters will do. No matter what they're building, it could be, in this case, a picture frame. It could be the floor of a shed to make sure that it is square, which means that the angles are 90 degrees. They'll take the two sides, they'll measure the length of the diagonal, and they'll use Pythagorean theorem to make sure the diagonal is the right length so that the sides are square. So that's what this is asking us to do. Calculate what the length of the diagonal must be for the frame to be square. So how long should the diagonal be so that there's a right angle at the corner? That's what square means. It means the corners are 90 degrees. So again, a squared plus b squared equals c squared is Pythagorean theorem. The two legs are a and b. Again, you can switch those two around, but the hypotenuse always has to be c. So we said that little a was 40, little b is 50. So 40 squared plus 50 squared is what the left side is. That's 4,100. That's what c squared equals. So now we'll take the square root of both sides to find out what c is. So it says to the nearest inch, so approximately 64 inches. Rounded to the nearest inch. Number 4 says Jeanette needs to clean her eaves trough. She owns a 20-foot ladder, which means that's how long it is. She wants to know how high up the side of her house the ladder will reach if she puts the bottom of the ladder 5 feet from the house. So again, we always start with a right triangle. You cannot use Pythagorean theorem unless you have a right triangle. The ladder is 20 feet long. So that's the hypotenuse. The ladder is leaning up against the house. And the foot of the ladder is 5 feet from the house. That's that number at the bottom. In this case, we want to know how high up the house the ladder reaches. That would be h. So in this case, the two legs are a and b. The hypotenuse, the side across from the right angle, is c. This is one of those examples where we're given the hypotenuse. We want to find one of the two legs. But we always start with the Pythagorean relationship. I said that little a was 5. And c is 20. Now on the video, yes sir. So that's what I'm going to do next. On the video, he squared the numbers first and he subtracted them from both sides. But we can subtract 5 squared from both sides and it's the same thing. It just saves us one step. But that'll now give us b squared by itself on the left. And on the right, I can do that on my calculator. 20 squared, take away 5 squared. That's 375. And now we'll take the square root of both sides. To get b, and we're going to round that to the nearest foot, it says, which would be the square root of the 375. Approximately 19 feet to the nearest foot. Right, so You always have to make sure that you label the hypotenuse as C. The other two sides, the legs of the triangle, are A and B. And as long as you label the hypotenuse as C, you should be fine. So always start with that. Example 5 says that Molly is building a shed. The floor will be 5 meters by 11 meters. She begins to cut out an area where she'll pour the concrete base of the shed. However, the corner does not appear to be at a right angle. When she measures diagonal, it is 11.7. So what should the length of the diagonal be? So if the two legs of the triangle, the two sides of the shed pad are 5 meters by 11 meters, what should the diagonal be? So let's check that out. A squared plus B squared must equal C squared. I'll say that A is 5, B is 11. The hypotenuse, side across from the right angle, is always what, Brooklyn? What, Brooklyn? Hello, Brooklyn. We're all waiting for you to answer. Pardon me? Are you supposed to be doing that? No. At least was it a good song? Okay, well that makes it kind of okay, but not really. Okay, so little a we said is 5, little b is 11. And again, we can do that in our calculator. And you'll get 146 for 5 squared plus 11 squared. To find out what C should be, we'll take the square root of both sides. So we need to take the square root of the 146. Approximately 12.1 to the 10th of the meter. So it should be 12.1. When she set it out and measured it, it's actually 11.7. It needs to be longer. So what that means is she needs to increase the angle between A and B. If you increase the angle between A and B, it'll make the side across from it longer. Okay? So that's how she would fix the problem. And, she would have to have a tape measure and measure out 12.1 meters and lay that along the diagonal, and that will tell her how much bigger that angle needs to be, so that the distance between the two ends there are exactly 12.1 meters. So how can she fix the problem? So increase the angle between 5 meters and 11 meters until the diagonal is 12.1 meters. And this is what carpenters do. For a situation like this, this is exactly what they'll do. Use Pythagorean theorem. Find out what the diagonal should be. Use a tape measure and lay it across the diagonal. And they'll move those two sides open until it gets to be the right length. You need to go. Okay? Okay. So we'll stop there for now. I'll hand out the assignment for you to work on. The solutions will be posted on Google Classroom so that you can check your answers.